I've had questions about the assignments on Edgenuity as far as adding and subtracting polynomials. So what I wanted to do is I wanted to create a video discussing some of the properties and definitions and some examples about adding and subtracting polynomials, because I know it can be a little bit confusing, it can be a little bit daunting. So what I want to do is I want to show you some examples on how to work some of these problems, what they might look like, and some of the steps that you could apply. Now, one of the things I will say about this video is I do know some students understand a lot of the content, or you understand, about half the content. So you may not need this whole video to answer some of the questions that you might have. So one of the things I'm going to do in this video is, if you look at the comment section or if you look at the description, I'm going to provide timestamps in order for you to look for the content that you need. For instance, let's say you already know these definitions, and let's say you're struggling with perimeter. Let's say you're struggling with finding profit using polynomials. What I'm going to do is, in the description, I'm going to provide the timestamps. You click on the topic that you feel like you need the most help with, and you can skip through on the video, because you may need some of this video, you may need all of it, or you may need none of it, and you just want to make sure you're doing the right work. But at the same time, I do want to make this as easy as possible for you, and I want to make your life simple. So if I could do that by putting the timestamps, then that'll help. All right. So again, if you want to look at the description, if you want to look below in the comments, and you want to skip through the video to find the section that you need, you're more than welcome to do that. If not, I will just get started with discussing adding and subtracting polynomials. So one of the first things you're going to have to know is, before you start adding and subtracting polynomials, right, is one of the first things you're going to have to know is some of the definitions. So let's discuss what a polynomial is, and let's discuss some of the important definitions. So I'm going to start with the first thing, which is something called a monomial. Okay, so a monomial is whenever you have one term in an algebraic expression. Now, what a term is a term is usually a statement that we make in, an expression is a statement that we make in math that consists of terms. Now, terms are usually separated by pluses or minus. So one of the things you're going to notice about monomials, binomials, and trinomials, and even polynomials, is the amount of pluses and minuses that you see in these expressions. All right, so I'm going to start with the monomial. So a monomial would be something like 3x. We consider 3x one term because you have the value of 3 and you're multiplying it to x. But if you notice, 3 and x aren't being separated by a plus or a minus sign. So we consider this one term. All right, so this is one term. So if we only have one term in an expression, well, we call that a monomial. Similarly here, we have a negative 7a. Now, don't confuse this negative with the minus sign, because again, it's at the beginning of the expression, so we consider it a negative. But again, this negative 7 and this a are being multiplied, so we consider this one term. Similarly here, I have a 2 and I have an x squared. Again, the 2 and the x squared are just being multiplied, so we're going to consider this one term, which is, again, is a monomial. And then here, we have 4xy cubed. Now, if you look at it, you might be asking, well, wouldn't you consider this two things, because now you have two variables? But if you pay close attention, notice how none of these things are being separated by pluses or minus. So what we do is, since they're not being separated by plus or minus, and instead they're being multiplied, we just consider these one term. Similarly here, negative 5c to the power of 4b to the power of 5. Again, we're going to consider this just one term because there are no pluses or minus. So anything that just deals with one term, we're just going to call that a monomial. A monomial. One term, monomial, okay? Now, the next thing I'm going to look at is something called a binomial. Well, binomials, if you think about like a bicycle, it's called a bicycle because it has two wheels. So binomial, right, just means two terms in an algebraic expression. Now, the way you're going to know how many terms there are, again, is you're going to look for the pluses and the minus signs, right? So let's look at the examples that I provided below. So in this first example, I have 3x plus 5. Well, if I think about 3x, that's considered one term. And if I have a plus 5, this is considered one term. And if I count them correctly, this gives me two terms. And anything that has two terms in an expression is just considered a binomial, okay? Similarly here, negative 6a plus 5. Again, two terms, this will be a binomial. And again, the key is to look for these pluses and minus signs. They're going to separate the terms for you. So as long as you can locate them, you know where they are, and you can count how many terms you have, you can identify the monomial, binomial, trinomial. Okay, so we're going to look at this example right here. It's 3x minus 5b. So again, this is two terms, so this is going to be a binomial. Again, we're looking for the clue, which is a minus sign here. And then again, I already see a plus sign, so there's more than likely two terms here, so this will also be a binomial. Right, and then the last type of polynomial that we will discuss is something called a trinomial. Now, a trinomial, if you think about a tricycle or a triangle, the word tri, right, means three. So we're looking for three terms in an algebraic expression. Right? So again, my clue to know how many terms I have is I got to look for the pluses and the minus sign. Now, if I look at this, there is one plus and there's one minus sign, which splits this expression into three terms. So since there's three terms, I'm going to consider this a trinomial. All right, similarly here, again, you might look at this and you might say, well, isn't this more than one term? Well, no, because this x to the 5 and y cubed aren't being separated by a plus or a minus, so I'm going to consider this one term. Here's a plus sign, I'm going to circle that. Here's a term, and then here's another minus sign. So if I count these carefully, right, there are three parts, so this is going to be a trinomial. And again, right here, 7ab squared minus 8a squared y plus 4a squared to the 5, three terms. This is going to be considered a trinomial. All right, so again, monomial, one term, binomial, two terms, trinomial, three terms. And your clues to figure out what kind of polynomial you have is to look for the plus or minus signs. Those will usually tell you when you're splitting up terms. Now, let's say you get an example and it has more than three terms. Let's say you have one with four terms or five terms or even six terms. Well, what we call those is we just call those polynomials. Polynomial is just a way to generalize, more than one term. So anything that has two or more, we can consider that a polynomial. All right. So the next thing we're going to look at, the next definition we're going to look at is one of my favorites, which is something called a degree. And a degree is actually pretty simple because all you have to be looking for is for a degree, you just have to be looking for the largest exponent of a variable. So you're just looking for the largest exponent, all right? So let's look at some of the examples and let's figure out what the degrees are, all right? So if I look at this first example, very simple, it just says 3x, right? And I'm looking for the largest exponent of a variable. So a variable is just a letter, which in this case happens to be x, so here's my variable. And I need to find the exponent. Now, if you look, there is no exponent here, but I know your algebra teachers taught you well, and they always say, well, if you have a variable, but it doesn't have an exponent written, you assume that there's a 1 there, right? So if I'm looking at this expression 3x, right, there's a degree of 1, or there's an exponent of 1, I'm sorry, right? I'm going to look for the largest exponent. Well, the only exponent I see is a 1, so the degree of this expression must be 1. In the next example, I have negative 7x squared. I'm going to locate the variable, which is x. I'm going to locate the exponent, which is a 2, and it's the only exponent I see, so it must be the largest, so the degree of this expression must be 2. In the next example, I have 8b to the power of 5. Here's my variable, here's my letter, here's my exponent. It's the largest exponent I have, so the degree of this must be 5. Now, if you look at this next example, they're really trying to trick you here, so don't fall for this. I know if you say, I'm going to look for the variable, and there's two variables again, right? So you might say, well, I'm just looking for the largest exponent, so the degree must be 7. Well, that's not the case, though. If you remember this y, it doesn't have an exponent written, but if you remember from the first example, we're just going to put a 1 right here, right? Now, if you notice this x and y aren't being separated, they are not being separated by a plus or a minus sign. So since they're not being separated by a plus or a minus sign, I'm going to have to actually add the exponents of these two, and that's going to give me the degree of the expression. So what I mean by that is the first exponent that I have is a 7, and since it's being multiplied to this y to the 1, I'm going to have to add a 1 also. So if I do 7 plus 1, that's just going to give me 8. So the actual degree of this expression is just 8. All right? So don't forget, right? You can consider these together since there's no plus or a minus sign. So let's look at the last example. If I look at the last example, right, this is a trinomial because, again, there's three parts, right, and they're separated by a minus and a plus sign. But again, each term, right, that I'm about to take, so I'm going to take this term, and this term, I'm going to need to find the degree, or I'm going to need to find which one of these has the highest or the largest exponent. So what I do is, again, this a squared and this b cubed, since there's no plus or minus separating them, I'm actually going to have to add the exponent. So this one has an exponent of 2, and then this b has an exponent of 3, so I'm going to add these together, and I'm going to end up with 5, all right? This negative 2, or minus 2ab to the power of 6 is, again, this a, you should know it has an exponent of 1. And since it's being multiplied with this b to the 6, I'm going to add the two exponents. Because, again, degree is just exponents, right? I'm going to add them, and I get 7. And then over here, I have a to the 5b cubed. So I'm going to add the two exponents since they're together, 5 plus 3. And I end up with 8. Now, some of the misconceptions students might have is they might look at this right away and say, oh, well, 6 is the largest exponent. But again, since it's together with the other variables, you have to make sure that you add them. Now, the other thing is you're just looking for the largest number. So what you do is you take all three of these exponents and you decide, well, which one of these is the largest exponent? Well, if I look at 5, 7, and 8, I should know, well, 8 is the largest number between 5, 7, and 8, so the degree of this expression must be 8. So keep that in mind whenever you're discussing degrees, all right? Know when to add the exponents, and always make sure you're looking for the largest exponent of a variable, all right? So always keep that in mind. So let's look at the next section. So the next thing we're going to talk about is combining like terms. Now, combining like terms is something that I know you've heard the teachers talk about, especially when you were solving equations, but I just want to go over it again just to make sure that we understand what it means to combine like terms, and when it, especially with these polynomials and these expressions, when to combine like terms and when it's not the time to combine like terms. So by definition, combining like terms, the terms must have the exact, and I mean exact, same variable or variables and the same degrees. So keep that in mind, same variable, same degrees. So what do I mean by that? Well, if I ask myself, am I allowed to combine 2x and 6x? Well, the first thing I ask myself is, do they have the same variable? Yes. Do they have the same exponent? Well, they both have an exponent of 1, right? Because we're going to fill them in with a 1. So I am allowed to combine them, so that's good to go. Same thing here. I look at the variable, which is y. I look at the exponent. Are they exactly the same? Yes. So this is good to go. Same thing here. I have 6x squared and a negative 2x squared. Now, for now, I'm not going to focus on these coefficients, the first numbers and the expressions, because remember, just to combine like terms, they just have to have the exact same variable and same degrees, but I will focus on them right now when I talk about adding and subtracting. So I look at the variable and I notice that they both have x and they both have the exact same degree, which is the 2. So assuming that they have the same variable and the same degree, I am allowed to combine these terms. Now over here, again, remember this is one term because there's no pluses or minus, and then this is another term, right? So I have an x squared and a y cubed, and over here I also happen to have an x squared and a y cubed. So since they both have the same variable, and those variables both happen to share the same degrees, because notice how the x's have 2's and the y's have 3's, I am allowed to combine them, all right? Now, don't fall for some of the traps that they might give you, right? What if they give you an example like, let's say, 4x squared y cubed, and they ask you, well, you need to combine it, or let's say they don't even ask you, but you're wondering if you can add, like, let's say 4x squared y cubed plus 6x, we'll say cubed y squared. Well, if you look at this quickly, it might kind of trick you, and you might say, oh, well, yeah, they have the same variables, same exponents. But look at them carefully, right? So we look at the variables first. They both share x's, okay, and they both have y's, which is good. But if you look at the exponent for the x, it has an exponent of 2, and this x has an exponent of 3. And then similarly, the y has an exponent of 3, and this y has an exponent of 2. Now, at first glance, when you first saw it, you might have thought that they're exactly the same, but if you pay close attention, the exponents are off. So this, I'm not allowed to combine them. Even though they do look similar, I'm not allowed to combine them because they are not exactly the same. So keep in mind that you do have to make sure that they are exactly the same. Now, some of the properties that I do want to discuss is something, there are 3 properties that are very important, and I'm going to start with one of the ones that I feel is the most important, which is something called the commutative property. Now, if you notice, I highlight the words changing the order, okay, or you could call it rearranging. But anytime you change the order, you should think, oh, I'm changing the order, I'm rearranging things, that's the commutative property, all right? So by definition, the commutative property is just changing the order of 2 or more terms. And as long as you change the order of 2 or more terms, it does not affect the result or the final answer. Okay, now notice how this only works under addition and multiplication, so keep that in mind, addition and multiplication. Right? But for now, we're only going to focus on the addition part, all right? So here's an example. I have 8x to the power of 4 plus 3x squared, all right? So what I do is the commutative property allows me to rearrange these things. So what I mean by that is notice how this 8x to the power of 4, it's over here also, 8x to the power of 4, and then this 3x squared is over here. And all I did was I took this 3x squared and I moved it from the back, and I took it to the front, and then I took this 8x to the power of 4, and all I did was I moved it to the back. All I did was I changed the order, or you could say I rearranged it, all right? But notice how I didn't change anything about these. The 3 still stayed with the x squared, and the 8 still stayed with the x to the power of 4. So as long as I keep the values similar, and I don't change anything, all right, I am allowed to rearrange under the commutative property, all right? Similarly here, let's say I wanted to take 2x to the power of 7 minus 6x cubed. I want to make sure that it's equal to negative 6x cubed plus 2x to the power of 7. Well, what I do is I look at this 2x to the power of 7, and I compare it to this one. Is it still 2x to the power of 7? Yes. Now, you might say, well, now there's a plus sign in front of this 2x to the power of 7. But again, this was a positive 2x to the power of 7, so this plus sign does belong here, all right? Now, this minus 6x cubed, I moved it to the front, and notice how the negative 6 stayed the same, or the minus 6, and the x cubed stayed the same, okay? But if I am going to rearrange, keep this in mind, that since this was a minus, when I do move it over, I have to keep the minus or a negative sign in front of the 6x cubed. So make sure that when you do rearrange, right, you are allowed to rearrange, but make sure the values stay the same. This 2x stayed positive, the 6x, this negative 6x stayed negative, all right? Now, you've actually seen the commutative property before. If you think about it with just numbers, right, you might have a friend that might ask you, well, what is 2 plus 3? And you tell them, well, that's just 5, right? And that is true, 2 plus 3 is 5. Now, what if you turned around, or what if they asked you, well, is it the same thing as 3 plus 2? Well, under the commutative property, as long as I keep the values the same, I'm allowed to rearrange them under addition. So if I look at 3 plus 2, notice how that's still equal to 5. So the answer still stayed the same, even though I rearranged the order, all right? So let's look at another example down here. We'll work some out real quick. So I have 6a cubed plus 7a. So if I want to rearrange these, all I want to do is I want to take the 7a and now I want to move it to the front, right? And again, it stayed positive because there was a plus sign in front of it. And then the 6a cubed, I want to move it to the back, but I can't, just put 6a cubed. I need to put a symbol to separate these two. And since this is a positive 6a cubed, I'm going to put a plus symbol. So this is plus 6a cubed. And under the commutative property, I'm allowed to rearrange it. Now here, what I'm going to rearrange is, I know I have 4 terms, right? Because I have minus, plus, minus. But what I'm going to do is I'm actually going to rearrange these, but I'm going to keep these terms, right, these binomials, if you actually think about them, inside of the parentheses. So what I'm going to do is I'm going to take this set of parentheses, I'm going to move it to the back, and I'm going to take this set of parentheses, and I'm going to move it to the front. So what I'm going to do is I'm going to take this, and I'm just applying the commutative property, right? I'm going to open a parentheses. I'm going to put 9c to the power of 6 minus 4c squared. So I'm going to leave that alone. So now I move this to the front. Now there's a plus symbol here, right? So this was positive. That's why I didn't put a symbol in front of it. Now there is no symbol here, but since there's no symbol, we're going to assume that it's positive. So I'm going to put a plus symbol there. And all I'm going to do is I'm going to move this to the back. So 2b to the power of 6 minus, because I'm not changing the values of these. Remember, you don't change the values, minus 3b squared. All right? So if I look at it carefully, all right, I applied the commutative property. I rearranged these two terms. And if I were to work this out, the answer would not change. The final answer would actually still be the same. So it's a pretty cool property to use, all right? Now, besides the commutative property, we have 2 other properties, right? The closure property and the associative property. Now, to be honest with you, the closure property is not one of the properties that I cover a lot, but I actually think it's really fascinating. So the closure property just says that the sum of 2 polynomials is just another polynomial. And that kind of makes sense, because if I add 2 polynomials, well, I would hope that the answer is another polynomial. Similarly, like if somebody gives you 2 numbers, well, if you add 2 numbers, hopefully the last answer happens to be a number as well. So what the closure property pretty much says is, if you take this example, like let's say 3z to the power of 4 plus 2z cubed plus 2z to the power of 4 plus z cubed, it just says if you take this polynomial or this binomial and you add it to this other binomial, well, notice how you get a binomial or another polynomial at the end, all right? Now, I know I haven't discussed adding and subtracting yet, but if you trust me, they just combined these 2 terms and then they added these 2 terms right here because they have the same variable and same exponent, and then similarly here. But the idea is pretty simple. Closure property just states if you have a polynomial, you add it to another polynomial, the final answer will just be another polynomial. Now, I know I did put the word sum here, but it also works for differences. It pretty much just states that if you take a polynomial and you subtract another polynomial, then the final answer is just another polynomial. If you forget the definition, you could always write this down or just look back at the video and remember what the closure property states. Now, the last property that I'm about to cover is the associative property. Now, the associative property is pretty cool because the associative property just states that whenever you're grouping 2 terms together, it won't result in a different answer. So what does that mean? Well, let's look at this example. I have 6x cubed plus 7x cubed plus 4x squared, but notice how this 7x cubed and this 4x squared are together inside of parentheses. So what I'm going to do is, if I look at this, the associative property, what it allows me to do is, if I notice this x cubed, right, this 7 also happens to have an x cubed. So what the associative property lets me do is, instead of adding these 2 terms first, because they're in parentheses, it actually allows me to add the x cubes first, and then add the 4x squared at the end. And it will not, and I promise you, it will not actually result in a different answer. You'll actually get the same answer back. An example, and you can see this with numbers, is think about it like this. Like, let's say you have 4 and you want to add it to 6 plus 5, right? So if we follow order of operations, normally we would do the 6 plus 5 first, right? So we have 4 plus, and then 6 plus 5 is just 11. So 4 plus 11, and if you think about it, 4 plus 11 is just 15. Well, what if I wanted to apply the associative property, since this is addition, and instead of adding 6 and 5 first, I wanted to add 4 and 6 first, and then add 5 at the end. Well, if I think about it, 4 plus 6 is just 10, and if I add 5, well, I still end up with the answer of 15. So notice how the associative property allows me to combine these 2 terms together. And you're actually going to use this whenever we discuss adding and subtracting, because it's important to combine like terms. It's important to group stuff together that's similar, right? And it won't actually affect our answer. So let's apply the associative property here. So I have 4x to the power of 5 plus 2x to the power of 5 plus 7x. If I notice, these both have x's to the power of 5. So instead of adding 2x to the power of 5 plus 7x first, what I'm going to do is I'm actually going to add this 4x to the power of 5, and I'm going to add it to this 2x to the power of 5 first, and then I'm going to add the 7x at the end. And I'm allowed to do this because I'm following the associative property. I'm not changing the values of anything. And since this is addition, all I'm saying is I want to add this first and then add the 7x at the end. All right. So the next thing we'll look at is something called the additive inverse. And the additive inverse, right, seems like a term we don't really hear too often, but it's actually a really fun and easy term, right? So by definition, the additive inverse is just a number or a term that when added to another number or term results in a zero. So the easiest way that I remember it is I kind of just think it's the opposite sign of whatever they give me. For instance, here's an example. Let's say they gave me the number 8, and they wanted to know, well, what number, right, could I add to this number, to 8, that will give me a 0? Well, if you think about it, I have 8. In order for me to go back to 0, I have to go back 8, and when we go back, we call it subtraction. So in other words, the number that I would have to add to 8 is just negative 8. So if I add 8 and negative 8, it's going to give me 0, and I can actually verify that with a calculator. If I take 8 and I add negative 8, right, notice how I get 0. All right, so this just shows that that is the additive inverse, right? Let's look at negative 3. Well, if we apply the same rule, I kind of just have to think, well, what's the opposite of negative 3? Well, it's just a positive 3, right, or a plus 3. So the additive inverse of negative 3 is just a positive 3. Well, what if it says something like 7x? What signs do I need to flip? Well, all you would have to flip is just the sign of the coefficient, right? So just the 7. You don't actually need to turn the x negative, just change the value of the coefficient or the first number. So the additive inverse of 7x is just, well, negative 7x. Likewise, if I take negative 5x, its additive inverse would just be a positive 5x because it's the opposite. Well, what if I have something like this, 3x squared y? Well, if you remember, again, for additive inverse, I'm just looking at the coefficient of the first number. I'm going to keep this together, so I'm not going to change anything. And again, this is one term. This is a monomial, right, because there's no pluses or minus. So what I do is I'm going to take the opposite. I'm going to take the additive inverse of 3, which just happens to be a negative 3, and then I'm going to leave my variables and exponents the same, so x squared y. Right? I'm not going to change anything there. So I'm going to apply that rule here. But I have a negative 6 this time, so the additive inverse would happen to be 6a cubed b squared. All right. Now what about this over here? Now if you think about it, remember, there's a minus and there's a plus, so this is a trinomial because there's 3 terms. So when you take the additive inverse of these terms, you have to take the additive inverse of each term. So what I mean by that is you're going to take the additive inverse of 7, of negative 4, and of this positive 3 or this plus 3. So the additive inverse of 7x squared y would just be negative 7x squared y, right? And the additive inverse of negative 4xy squared would just be a plus 4xy squared, right? And then the additive inverse of a plus 3x squared would just be a minus 3x squared. So that's how you take the additive inverse, right? Just think about turning, changing the sign, opposite sign. And again, you only change the sign of the number. You don't deal with the variables. You don't deal with the exponents. Variables and exponents will just stay the same. So as long as you know what the examples look like, and as long as you know what additive inverse is, you should be able to find the answers fairly easily, right? Now let's actually get into the math section of this, right? Now, how can I take all the stuff that I've learned and apply it to the questions that they're about to give me? What if they ask me to add polynomials, or what if they ask me to subtract polynomials? Well, what I'm going to do is I'm just going to take all the properties that I know, and I'm going to apply them, and I'm going to figure out what the sum of these polynomials are. Now remember, these all follow the closure property. If I add polynomials, my final answer should also be a polynomial. So how do I apply these? Well, here's what I'm about to do. What I like to do first is I like to separate these, right? So what I'm going to do is I'm going to take 8x squared. I'm going to remove this from the parentheses, plus 4. All right, and since this is a plus sign doesn't affect any of these signs. So what I'm going to do is this is just going to turn into a plus 2x squared. This is going to stay, as a minus 6x, and then this is going to stay as a plus 3. Now what I like to do is I like to take colors, right? So I'm going to change the color red, and I like to highlight the things that are similar. I like to underline them. That way I can keep track of the things that I'm about to combine. So what do I mean by that? Well, if you remember, whenever I combine like terms, they need to have the same variable and they need to have the same exponent. So what I'm going to start is by looking at this 8x squared, and I'm going to underline it red. Well, I'm going to look at the other terms, and I'm going to see if any others have an x squared. If I look at this 4, it doesn't have an x squared. If I look at this 2, it does have an x squared, so I'm going to underline it red. X, it does have the same variable, but not the same exponent. And then 3, it doesn't have anything, so I'm going to switch to another color, okay? What about a 4? Well, a 4 doesn't have any variables, and it doesn't have exponents, so we'll just call it a number, so I just got to look for other numbers. So if I look at this example, this is not just a number because it has an x, and then this one is a number because it's just a 3, and then I'm going to highlight the last term blue. So all I got to remember is my red terms, just combine my red terms. My green terms, I'm just going to combine my green terms. And then my blue term, well, there's nothing to combine it with, so I'm just going to bring that down. All right, so let's start by combining these, right? Now, what you could do is, since these have an x squared, is you know that when you combine them, they should also have an x squared, right? And all you have to do is just add the numbers that are in front. So I'm going to take 8 plus 2, all right? So 8 plus 2, that just happens to be 10, so I have 10x squared, all right? Next, I'm going to take the Greek term. So I have a plus 4 and a plus 3. So if I have a plus 4 and a plus 3, well, that's just going to give me plus 7. And then the last thing I'm going to apply is this minus 6x. Since it had nothing to combine with, I'm just going to bring it down. And then last but not least, all I'm going to do is, usually my final answer doesn't look like this, and I'm going to write the final answer in black, but I'm going to apply the commutative property, which tells me that I can rearrange these terms, and I'm just going to put them from highest exponent to lowest. So what I'm going to start with is I'm going to start with 10x squared, because that's the highest exponent. Next is this minus 6x. So using the commutative property, I can rearrange these, but just make sure the minus stays with the 6x, and then don't forget the plus 7. So this would be your final answer right here. All right, and that's all you have to do. Just follow the rules that we've been follow the rules that we've been going over, and you should be good to go. So this right here, let me see if I can draw a better box. It should be your final answer, okay? So we're going to apply that rule down here. Now, if I notice, I do have some negatives here, but it's okay, right? As long as I follow my rules and as long as I do what I'm supposed to, I should get the final answer, all right? So I'm going to start by separating these, right? So I'm going to just bring them down. So I have negative 4x cubed plus 3, and since there's a plus sign right here, none of this is going to change, so I'm just going to bring this down, minus 5x cubed plus 2x minus 8. All right, let's figure out what this is equal to. Well, I'm going to take my colors, and I'm going to look for my exponents and my variables. So I have x cubed, so I'm going to look for another x cubed, and there's another x cubed right here. Now remember, this minus goes with this 5, all right? So if I look here, no x cubed, no x cubed. So next I'm going to move to green. Well, I have a number. Is there any other numbers that are by themselves? Yes, this minus 8. And then I'm going to look for this term right here. It has nothing to combine with. So all I'm going to do is I'm going to combine my reds together. I'm going to combine my green terms together because, again, they're similar. And then this blue term will have nothing to combine with. So I'm just going to bring it down. So let's start with the red term real quick. So on the red terms, I have negative 4x cubed plus 2x cubed. Now, let's say you struggle with adding negatives and positives. One of the things that you can do that you have at your disposal is, again, well, before I go to the calculator, remember, since these both have x cubes, I know that my answer is going to have an x cubed. And all I can do is I can actually go to my calculator and type in negative 4 minus 5. Negative 4 minus 5, and let's see what that gives me. So I just have a basic calculator, nothing special here. Negative 4 minus 5. That gives me negative 9. So the calculator tells me that this is negative 9, and that is correct. So it's just negative 9x cubed. So in case you struggle with the math, right, and it's okay if you do, don't forget you have that calculator, okay? Now, the calculator won't let you type in x's, right, but you should know that since these have x cubes, then the final answer should also have an x cubed. All right, next I'm going to go with my numbers. I have plus 3 and a minus 8. Well, if I know this, the 8 is a bigger number, so it's going to give me a minus 5. And then I have a plus 2x, which, oops, I forgot to put it in blue, so I have plus 2x. And all I have to do is apply the commutative property. Let me rewrite this in black from highest exponent to lowest. So I have negative 9x cubed, that is the highest exponent, plus 2x, and then last but not least, minus 5. All right. So that's one thing you could do. All right, so I'm going to go to one more example about addition, and I'll actually show you something different on this one, and it might help you. All right, but I'll show you two ways. I'm going to use my way, and I'm going to go a little bit faster here. Okay, so if you want, you can always slow the video down, pause it. All right, so what I'm going to do first is I'm actually going to rewrite these, right? So I'm going to, and this is addition, by the way. So this is negative 9a squared plus 5. And since this is addition, I don't have to change any of these signs. So minus a squared minus 4a plus 2. So what I'm going to do is I'm going to take my colors and I'm going to highlight the things that are underlined, the things that are similar. So I have a negative 9a squared and a negative a squared. I have a 5 and a 2, which are just numbers, and then I have this negative 4a. So what I'm going to do is I'm just going to combine like terms. So those two are going to combine. These two are going to combine, and then this one has nothing to combine with, so I'm just going to bring it down. So I'm going to start by doing the math real quick. Now, if you look at this, you might say, well, this a squared doesn't have a number. But again, how many a squares do you have? Well, you just have one. So I have negative 9a squared minus another a squared. That's just going to give me negative 10a squares, right? So if I look at 5, I have 5 plus 2. Well, that's pretty simple. That's just 7. And then this negative 4a, again, it has nothing to combine with. So you could just drop it. All right, last thing you're going to do is you're going to rearrange these in order. So negative 10a squared, because it has the highest exponent, minus 4a, and then plus 7. Now, one of the things you could also do, right, is if it makes this easier for you, is when you rewrite these, what you can do is you could put negative 9a squared, and you can go back to what we would do. I'm going to take this one, right? You can go back to what we do in elementary, and you're going to leave a space here, and you're going to put plus 5. So what you do is here you write your a squares, right? Here you're going to write your a's, and then here you're just going to write down your numbers, all right? And what you do is you go back to what we learned in elementary on how to add, all right? So you're going to put a plus symbol right here, and you have a negative a squared minus 4a plus 2. So what you can do is you can just add like you did in elementary. 5 plus 2, well, that's just 7. There's nothing here, so I'm going to put a 0. Well, what is 0 minus 4a? Well, if you have nothing minus 4a, well, then you just have minus 4a. And then you have a negative 9a squared plus another negative a squared, all right? Now, again, since this is negative, you're kind of just taking another one away, so you have negative 10a squared. So notice how I still get the same answer regardless of the method that I use. But if you find this a little bit easier, maybe that'll, maybe it will be easier, all right? So that's addition. So let's look at subtraction, right? Because it is important to look at subtraction also. I'm just going to make sure that I am recording. Okay, so I'm going to look at subtraction next. Now, when I do subtraction, there is one thing to keep in mind. It is very similar to addition, but the thing that you have to know about subtraction is that this negative is going to affect, right? It is going to affect the other terms at the end. So when I rewrite them, I got to make sure that I distribute this negative because it's changing the sign of everything, right? So keep that in mind. All right, so what I'm going to do is I'm going to start by rewriting. So this is just 8x squared plus 4. There's no negative here, so I don't need to change anything. But this negative, I need to make sure that I distribute it to every single term. And what happens is when you distribute it, it's going to change the sign of everything. So what does that mean? Well, I have a 2x squared. There's a negative, so now it's going to become minus 2x squared. This negative 6x, right? Now with the negative, it's going to turn into a plus 6x. And then this plus 3, since it's being affected by the negative, it's just going to turn into a minus 3, all right? Next, I'm just going to apply the rules that I used earlier, right? Now that I've rewritten it, right? Now that I've cleared up these parentheses, now I can just start combining like terms. So again, I'm just going to combine the like terms. I'm not doing anything special, just combining like terms, okay? So reds, these both have x squared, so I'm going to combine them. Greens are just numbers, so they're going to stick together, and then the 6x has nothing to combine with. So I'm going to start by combining these. So I have 8x squared, and I take away 2x squared again. It's going to be x squared, and if I have 8x and I subtract 2x, well, that just leaves me with 6x squared. If I have 4 and I subtract 3, well, that just leaves me with 1, or in other words, plus 1. And then this plus 6x, it had nothing to combine with, so I'm just going to put plus 6x. The last thing I want to have to do is just rewrite this in order, so I'm going to start with 6x squared. I'm going to move this plus 6x, applying the commutative property, and then I'm going to put plus 1. And that'll give me the final answer right here, 6x squared plus 6x plus 1. Why did I subtracted the polynomials? All right, same thing. I'm going to apply the same rules over here. Now you might think, well, there's a negative in the front this time, but it's not outside the parentheses, so I don't have to distribute it. So all I'm going to do is I'm just going to bring this term, or this binomial down, negative 4x cubed plus 3. Remember, this negative is going to affect all my signs in the parentheses, every single term, right? Every single term is going to be affected by this negative sign. So this negative 5x cubed, since it's being affected by this negative sign, it's going to flip to a plus 5x cubed. This plus 2x is just going to flip over to a minus 2x. And then this minus 8 is just going to flip over to a plus 8. So notice how this negative, all it did is it just changed the signs of everything, all right? Again, I'm going to take my color, and I'm just going to underline similar or like terms. So x cubed with x cubed, and again, it's a plus 5x cubed. Number with another number, and then this term, again, it has nothing to combine with, all right? So all I'm going to do is I'm going to combine these two terms together. So if I have negative 4x cubed and I add 5x cubed, well, the positive number is bigger, so I'm going to end up with x cubed. And if I have, and again, you have a calculator if you struggle with this part, but negative 4 plus 5, that's just going to leave me with 1x cubed. All right, next I'm going to take my numbers. I have a plus 3 and a plus 8. Well, that's pretty easy because that's just plus 11. And then this minus 2x has nothing to combine with. So the last thing I'm going to do is I'm just going to rewrite this to make it a little bit easier, right? So this x cubed, I don't have to write the 1, so I'm just going to write it as x cubed because, again, we should know that this is just 1x cubed. Minus 2x, and then don't forget about this plus 11. So we are allowed to rewrite this as long as we keep using the commutative property and we don't change the value of anything, all right? And I'll do one more example on subtraction, all right? So here's another example, all right? So again, all I'm going to do is I'm going to rewrite this. So again, the negative is not on the outside, so I don't have to change anything there, okay? But there is a negative outside of these parentheses, so I'm going to have to distribute it to each term. So I'm going to distribute it, I'm going to distribute it, and I'm going to distribute it. So what this is going to do is, let me rewrite this 5 real quick so it looks like a 5. All right, so what it's going to do is it's going to change this negative a squared into a plus a squared, or a positive a squared. It's going to change this negative 4a into a plus 4a, and then this 2, it's going to change it into a minus 2. All I'm going to do is I'm going to take my color. I'm going to underline like terms, right? So a squared with a squared, numbers with numbers, and then this, again, this happens to have nothing to combine with, all right? So I'm going to start by combining my a squareds. Well, if I have negative 9a squareds and I add 1a squared, because again, there should be a 1 right here, you could use a calculator, or you could just trust me that this is just negative 8a squared, right? Because I have negative 9 and I added 1. I'm going to take my numbers next, which I have 5 minus 2, which is pretty simple because that's just plus 3. And then this plus 4a has nothing to combine with, so I'm just going to put it as plus 4a. So last but not least, all I'm going to do is apply the commutative property and just rewrite this as negative 8a squared plus 4a and then plus 3. So that's how you can add and subtract polynomials, right? Now, besides adding and subtracting, one of the questions that's been asked before is something called an addend, right? And an addend isn't something that we see too often. It's not a term that we see, but it is something that we do need to know, right? Now, to find the addend, you just have to know the process to find addends, okay? And you have to know what the terms mean. So let me just explain what an addend is. So an addend, right, and every time you have a sum, you're going to have two addends. So keep that in mind that there are two addends. Is a number or a term that is added to another number or term to create a sum. So to create a sum. Now, if you remember a sum is kind of like a total. So the sum is what something will be equal to. So some examples, and I'll just start with numbers, right? Just start with number example. If the sum is 9, so again, this is the total, this is what it's equal to. One of the addends is 4, so I need to figure out what the other addend is, okay? So what you do is these are called addends, so you kind of got to remember these are the two things I add. So I'm going to add 4 plus, well, I don't know what the other addend is, so I'm just going to leave it blank. But I do know that the sum or the total is going to be 9, so 4 plus some number will be equal to 9. So what I do is I'm just going to go back to what I learned at the beginning of the year, which was how to solve equations, right? And I know that there's not a variable or a letter here, but we'll just leave that space blank. So you ask yourself, well, how do I get rid of this 4? Well, to get rid of a 4, I have to subtract the 4 because I don't need this 4 anymore. But you also got to remember, whatever I do to one side, I do to the other. So since I subtracted 4 here, I got to subtract 4 over here. So what happens is the 4s, they equal 0, or in other words, we can call it canceling out. So some number will equal to whatever 9 minus 4 is. Well, what is 9 minus 4? 5. So the blank must have been equal to 5. So the other addend must have been 5. And if you think about it, you remember, you take the two addends and you add them together. If you say 4 plus 5, well, is that equal to 9? Yes. So if the sum of the two numbers was 9 and one of the addends was 4, then the other addend must have been 5. So one of the easiest way to remember this, and this is the way that it's going to work out, is you can kind of just tell yourself this, is if you're only given one addend, you could just take, if you notice, all we did was we took this as the sum and we subtracted, right? We subtracted an addend, okay? So we subtracted an addend. So if you want to find out what the other addend is, we can just apply this process, which is the sum minus the addend, right? Will just equal the other addend, right? So it'll just give us what the other addend is. So we could apply this process and hopefully we can find the answer. So let me try to take this and apply it to this. So I'm just going to substitute, right? So sum is 4, so I'm going to put 4. Now this minus is by itself. It has nothing to do with this addend, so I'm going to put minus. Well, what am I subtracting? Well, the addend that they gave me was negative 3. Okay, and it'll be equal to whatever the addend is. Now, if you remember the rules of math, they always say when you have two negatives, they turn into a positive. This is technically 4 plus 3, which is just equal to 7. So the other addend must have been 7. And that makes sense, because if you take the two addends, negative 3, and you add 7, well, you have a negative and a positive, right? We could actually apply the commutative property if it makes it easier. 7 minus 3. Either way, right, this is just going to be equal to 4. So did it give us the sum? Yes. So how can I apply these rules to polynomials, right? Well, I'm going to use the same strategy, sum minus addend equals addend, and I'm just going to apply it over here to polynomials. Okay, so what I'm going to do is I'm going to take the sum, which in this case happens to be 8x cubed plus 2x squared plus 8, and I'm going to subtract this addend. Now keep in mind, when I do subtract it, I'm subtracting this whole thing, right? So I'm subtracting all of this. So what I'm going to do is to keep all of this together is I'm going to actually open up parentheses, and that allows me to keep this polynomial or this expression together, right? So it's going to allow me to keep this together. And since it's all kept together, right, this minus is going to affect every single term. So if we go back to what we did when we subtracted polynomials, remember this minus is going to affect every single term and it's going to change the sign. of all of these. So we have to apply that rule. So what I'm going to do is I'm just going to rewrite this as 8x cubed plus 2x squared plus 8. Don't forget what this minus does. It changes all the signs. So minus 6x cubed. Right, this minus 4x squared now turns into a plus 4x squared, and then this plus 5 turns into a minus 5. All right. So what I'm going to do is I'm going to take my colors and I'm just going to underline the things that are alike, right? So combining like terms. So x squared, there's another x squared, and then this blue, look, now I actually have three things that I can combine, a number with a number. So again, x cubed with x cubed, x squared with x squared, and then number with number. So I'm going to see if I can get some more space here. Okay. So what I'm going to do is I'm actually going to now start combining like terms. So I'm going to start with my x cubes first. So if I have 8x cubed and I subtract 6x cubed, well, that's just going to leave me again. It's going to be x cubed. Well, how many x cubes? Well, 2x cubes, all right? Next, I have 2x squared, and I'm going to add 4x squared. Well, that's pretty simple. That's just going to give me 6x squared. And then last but not least, I'm going to take my blue term. So I have a plus 8 and minus 5. So if I take 8 and I subtract 5, well, that's just going to leave me with positive 3, or in other words, plus 3. Now this right here, this is the final answer. I don't actually have to apply the commutative property because the exponents are already in order. All right, but if you want, I'll rewrite the final answer over here as 2x cubed plus 6x squared plus 3. And if you think about it, you could actually work this backwards and see if this was actually the other addend to give you this sum. So what I'll do is I'll take this addend, right, and I'll go back to, remember, if I add the two addends, I don't know if I wrote it down, but if I take the two addends, they should add up to the sum. So I'm going to take 2x cubed plus 6x squared plus 3, and I'm going to add it to the other addend. So I'm going to add it to, and again, I'm going to keep this addend together, 6x cubed minus 4x squared plus 5. Now, since this is addition, I don't actually have to change the sign. So I'm just going to rewrite this as 2x cubed plus 6x squared plus 3 plus 6x cubed minus 4x squared plus 5. All right. Again, I could just take my colors and I'm going to underline the things that go together. So those go together. This goes together with this. And then the numbers go together. And I'm just going to combine like terms. Now I'm going to write in black, right? Just to put the final answer together. So I have 2x cubed plus 6x cubed. That just gives me 8x cubed. All right, if I have 6x squared minus 4x squared, well, that just gives me positive 2x squared. And if I have a plus 3 and a plus 5, that just gives me plus 8. And notice how this was equal to the sum. So this must have been the other addend. This must have been the other addend that was added to this addend. I know I'm saying the word add a lot, but this must have been the other addend, all right? And it would give us this sum. So notice how I verified it and I checked. So if you need to find addends, this is the way to find addends. Take the sum minus one of the addends and you'll find the other addend. All right. So here we go. Well, one more example. All right. And this one will just apply the same rules. I know this one's a little bit longer, but we're going to apply the same rules. So I'll rewrite the formula just in case we need it. So if I take the sum minus one of the addends, it should give me the other addend. And this is what I'm looking for. I'm looking for the other addend. All right. So I'm going to take the sum, which is just 7x to the fourth, plus 3x squared y, minus 5x cubed y cubed plus 5. Now again, I'm going to subtract all of this, so I'm going to put parentheses to keep this together. And I am subtracting, so don't forget what subtraction does whenever we have parentheses. It is going to change our signs, okay? All right. So now that I've rewritten it, all I'm going to do is I'm going to rewrite this and I'm going to distribute this negative to every single term. That way I can write this correctly and I can start combining like terms. So this is just going to stay the same, 7x4 plus 3x squared y minus 5x cubed y cubed plus 5. Now this is going to change. So this was a positive 3x to the power of 4, so it's going to become a minus 3x to the power of 4. This is going to become a minus 2x squared y. This is going to become a plus 2x cubed y cubed. And then this is going to become a minus 4. Okay, so I'm going to need some more colors here. So what I'm going to do is, luckily I have 4 colors. So I'm going to see if I have anything that's similar, so or like, or equal, I should say, or exact. So I have x to the power of 4. It will probably combine with this x to the power of 4. I have x squared y, so I need to verify that I do have another x squared and a y, and yes, this does check out, so these are allowed to combine. Next, I'm going to have an x cubed y cubed. So do I have an x cubed y cubed? I do. So I'm going to combine these two. And then this one is just a number along with another number. Okay, so I'm going to take those and I'm going to combine them, all right? So I'm going to take these two, right, and I'm going to combine them over here. So I have 7x to the 4 minus 3x to the 4. Well, 7 minus 3 is just 4, and then the exponent's going to remain the same, x to the power of 4. Next, I have 3x squared to the y, at 3x squared y, I'm sorry, and then this is minus 2x squared y. So if I have 3 and I subtract 2, well, that's just going to leave me with 1x squared y, right? And again, we don't have to write the 1, but I'll write it down. And then here I have a 5x cubed y cubed plus another, or negative, I should say, a negative 5x cubed y cubed plus 2x cubed y cubed. So the negative number happens to be bigger. So it's going to be negative 3x cubed y cubed. And then let's just do the numbers. Hopefully we can see it in yellow. It's a little bit hard to see, but I do have plus 5 and a minus 4. So that's just going to leave me with a plus 1. All right, so what I'm going to do is I'm just going to write down the final answer. I guess I'll write this in black so it's a little bit easier to see. So all I got to do is just put the terms in order from highest exponent to lowest. So what I'm going to do is I'm going to put 4x to the 4. The next highest exponent happens to be a 3, so I'm going to take this one next. Okay, y cubed. And then I'm going to take plus, and I don't need to write down the 1, plus x squared y, and then plus 1. So all I did was I just rewrote it. All right, and remember, I just applied the commutative property to rearrange. Alright, so that's all I did. I'm just applying the commutative property. So as long as I follow this and I follow my rule, if I need to find another addend, I just remember I take the sum minus an addend and I can find another addend. Now again, I could always double check it. Right? We could always double check it to make sure that it does work. Right? And I hope it does work. So it should work out. I was just looking at it for a while just to verify that it does, but instead of trying to do it mentally, let me just actually work it out. So again, I'm going to take this addend and this addend. I'm just going to verify that they do check out. So if I take this addend, hopefully enough space here. So I have, well actually I'll just take this addend up here. So I have 3x to the 4 plus 2x squared y minus 2x cubed y cubed plus 4, and I'm going to add it to this one over here. Now again, I'm going to keep this together, but since I'm adding, it's not really going to change much. So I just want to verify, right? It's always good to double check. Now again, this plus symbol, it's not going to affect anything in the parentheses, all right? And again, I'm taking this addend, I'm taking the new addend to make sure that the sum is this, right? So, so what I'm going to do is, since this plus doesn't affect anything, I'm just going to start underlining the like terms. So x squared y over here with this x squared y, and then x cubed y cubed with this x cubed y cubed, and then number with number. Okay, so I'm just going to go ahead and start combining. So red with red. So if I have 3x to the 4 plus 4x to the 4, that's just going to give me 7x to the 4. If I have 2x squared y, I need to combine it with green, because remember, green with green. And over here I have 1x squared y, so now I'm going to have 3x squared y's. And then over here I have a negative 2x cubed y cubed minus 3x cubed y cubed. So if I have negative 2 minus 3, that's just going to give me negative 5x cubed y cubed. And then the last thing is the numbers, 4 plus 1, well, that's just going to be 5. So if I compare this, 7x to the 4, let's say 7x to the 4, plus 3x squared y, and I'm comparing it to this over here, that's still correct. So my final one should be a negative 5x and then a plus 5. So I do have a negative 5x and a plus 5, so this does happen to work out. Yeah. So it seems like a lot of steps, but again, it doesn't hurt to double check, but this is the way that you would find the other addend, right? And you may see questions similar to this, so even though it might seem like a process, don't be afraid to work these problems out because they are solvable, all right? So let's look at the next things. All right, word problems, all right? I know you're going to encounter some word problems, and we're almost finished with this, okay? So let's look at these word problems. They have to do with profit. So first you need to know what profit is, right? Profit is a financial gain, and it's the difference between the amount that you earn and the amount that you spend. So you can think of this in two different ways. You can think of profit as a formula of amount earned minus amount spent, or you can think of profit as revenue minus cost. In other words, anytime you have a business, you can sell products, but in order to sell the products, you need to make the products, and you can't make the products for free. You need to spend some money in order to create those products. So in order to figure out how much money you make, you take how much money you sold minus the amount that it cost you to make the products, and that'll tell you how much money you actually made. And the thing about profit is profit isn't always positive. Now in these questions, hopefully they are positive. But keep in mind, you're just taking what you sold minus what it cost you to make that product, and you find out the profit. So let's read this problem and let's see if we can figure it out. So profit is the difference between revenue and cost. So this is just what it means, revenue minus cost. The revenue in dollars of a company that manufactures bikes can be modeled by the polynomial 7x squared plus 2x. The cost in dollars of producing bikes, so in other words, to make the bikes, can be modeled by 7x squared minus 15x plus 200. And the variable x is just the number of bikes sold. So what expression represents the profit? So I want to know the profit, and what is the profit? 200 bikes are sold. So the first thing I need to do is, I almost forgot to underline this. First I need to find the expression, okay? So first I need to find the expression. So what I'm going to do is I'm going to know that this expression deals with revenue because it says the revenue can be modeled by this polynomial, and then this must be the cost over here. So what I'm going to do is I'm going to apply the formula that I was given, that profit must be equal to revenue minus the cost. So the revenue is just 7x squared plus 2x, right? And this is together, so I'm just going to put this in parentheses. And I'm going to subtract the cost, and the cost is this, 7x squared minus 15x. Now, since this is a subtraction problem, keep in mind that this negative, again, it's going to distribute to all of these. So we're going to have to distribute this negative to all the terms. And what it's going to do, it's going to cause the terms to change signs, right? So what I'm going to start with, I'm going to start by rewriting this. So there's no negative here, so I just write this as 7x squared plus 2x. Now this minus is going to affect the 7x squared because it's going to turn into minus 7x squared. This is going to turn into plus 15x, and then this is going to turn into a minus 200. All right, so what I do is I'm going to underline the things that I can combine. So I have an x squared and I have an x squared, right? I have a 2x and I have a 15x because they both share x's, and then I have this number that's by itself. So I'm going to combine the red terms together. So if I have 7x squared and I actually subtract another 7x squared, if you remember, this is just the additive inverse. And if you remember additive inverse, it just says that this is equal to 0. So these actually cancel each other out, or they go away. So I actually don't have anything left here besides a 0, which I don't need to write. I can pass the step. So next I'm going to combine the 2x and the 15x. That's going to give me 17x. And then this minus 200 has nothing to combine with, so I'm just going to leave it like this. So the expression that represents the profit, because again, I just applied the formula for profit, is probably going to be 17x minus 200. Now the question says, besides finding the expression, so this is answer number 1, right, is I also need to know, what if I sold 200 bikes, what would my profit be? Well, if you remember the rules that we've learned in algebra, and it kind of gives you a clue right here, it says the variable x is the number of bikes sold. So it's telling me that x must stand for the number of bikes I sold. So if I want to know the profit for 200 bikes, all I can do is I can take this 200 and I can substitute it for x, because remember, x just stands for the number of bikes sold. So what I'm going to do is anytime I see an x, I'm going to replace it with the number 200. So right here, I'm going to take 17, and wherever I see x, I'm going to put the number 200, and then I'm going to put minus 200, okay? So I probably need a calculator for this, so let me figure out what 17 times 200 is, right? So I'm going to go to my calculator, I'm going to clear it. So I'm going to take 17 times 200, it should give me a big number, right? 3,400. So I have 3,400. Now this minus 200, I didn't do anything with it, so I'm just going to bring it down. And then I can input this in the calculator. Well, what is 3,400 minus 200? So I'm just going to take that number and subtract 200. It gives me 3,200. So how much money would they make if they sold 200 bikes? Well, they would make $3,200. And that would be the final answer. All right, so pretty straightforward. But just remember, profit is equal to the revenue minus the cost. So we'll look at another example. All right, so we'll look at another example to see if we can apply the same rules, okay? So example number 2, and I'll write the formula up here just so we can, have the formula on hand. So again, profit is just equal to revenue, let's go this right, revenue minus the cost, okay? So profit is the difference between revenue and cost, which we just wrote down right here. The revenue in dollars of a company that manufactures headphones can be modeled by the polynomial 5x squared plus 100x. The cost in dollars of producing headphones can be modeled by 5x squared minus 40x plus 250. The variable x, so it's already telling us what x is equal to, is the number of headphones sold. So if 160 headphones are sold, what is the profit? So this one doesn't want the expression, but I'm going to need the expression. But it does want to know if I sold 160 headphones, what would the profit be? So I'm just going to apply this formula, revenue minus cost. And again, if I read it carefully, revenue is this expression, and then cost is the second expression. So what I'm going to do is I'm going to write this down. I'm going to write down my two expressions. So I'm going to take revenue, which is 5x squared plus 100x. I'm going to keep this together because all of this is revenue. And I'm going to subtract the cost, and I'm going to keep it together with parentheses, 5x squared minus 40x plus 250. By now, you should see, since we're doing subtraction, again, I'm going to change all of these signs, right? So all of these signs are going to change. So what I'm going to do is if I have 5x squared, I'm going to rewrite this as 5x squared plus 100x, because this doesn't change because there's no symbol in the front. But this is going to change to minus 5x squared plus 40x, and then minus 250. All right. So what I'm going to do is I'm going to underline my terms, and I'm going to underline the like terms. So x squared with x squared, x is with x, and then a number by itself. And what I'm going to do is I'm going to combine these like terms. So I'm going to combine the red ones together. I'm going to combine the green terms together, and then the blue one, again, it has nothing to combine with. Okay. So 5x squared minus 5x, again, this is just the additive inverse because they're the opposite. So these actually just cancel out, so we don't need that. If I have 100x and I have 40x, well, that's just going to give me 140x. And then this minus 250 has nothing to combine with, so I'm simply going to bring it down. So this must be my expression, 140x minus 250. But again, I don't need to know the expression. What they want to know is if I sold 160 headphones, what would the profit be? Well, if you go back, again, the number of headphones sold is just X. So similar to the last question, wherever I see X, I'm just going to replace it with 160. So I have 140. Again, I'm going to replace this with 160, and then I'm going to subtract 250. Now, this is going to give me a big number as well, but again, I have a calculator, so that should be easy. 140 times 160. So let's see, what do I get? 22,400. So I'm going to get 22,400, and then I'm going to subtract the 250 at the end. So I'm going to take this number and I'm going to subtract 250, and that's going to give me my final answer, which is 22,150. It's going to be, I believe, dollars, so it's going to be dollars. All right, $22,150. So if this company sold 160 headphones, it would make $22,150. All right. So that's how we figure out the profit. All right. So if you get questions about profit, you can always look back at these examples. All right. So let's look at the next example, which is perimeter. So perimeter is something that we learned in elementary and in middle school, right? Perimeter, by definition, is just the measurement of the distance around a figure, and it's only the outside. Remember, we don't count the inside, right? So let's look at an example. It says, Tom cut a triangle with side lengths, right? And the triangle has three sides, so there has to be three side lengths. 5x squared minus 1 inches, 5x squared minus 8 inches, and 5x squared minus 3 inches. Which expression can be used to find the perimeter of the triangle, and what is the perimeter when x equals 1.2? So the first thing I need to know is perimeter means that you add all sides. So I'm going to make this note right here. You have to add all sides. Right, so what I'm going to do is I'm going to take these sides right now. I know they don't give me numbers, but they do give me expressions. Okay, so I'm just going to add all the sides. So I'm going to take this first expression, which is 5x squared minus 1, and I'm going to keep it together with parentheses. Now, since I'm adding, I put a plus sign to separate these. So I have 5x squared minus 8, and then the last side is going to be, I'm going to add again, 5x squared minus 3. So when I add, remember, adding doesn't change the signs inside the parentheses. So I can rewrite this as just 5x squared minus 1 plus 5x squared minus 8, and then plus 5x squared minus 3. Okay. So what I'm going to do is I'm going to take my colors, and if I notice, this time I actually have more than one thing I can combine, because all of these have x squared, and all of these are just numbers. So I'm actually going to combine three things at once. Now, what I can do is when I combine these, is I can always take a calculator, but just to speed this up, I'm just going to add them here. So if I have 5 plus 5, that's just going to give me 10, plus another 5 is 15. So I have 15x squared. Right, and then I'm going to add up my numbers. So I have negative 1 minus 8 minus 3. So I have negative 1 minus 8. That's just going to give me negative 9, and then minus another 3 is going to be minus 12. So the expression, right, because they want the expression, if we ask which expression, it's just 15x squared minus 12. So that's the perimeter, okay? So this would be the perimeter right here. I'm just going to put perimeter. Oops. I'm just going to put perimeter. So this is the perimeter. Okay, but they want to know, well, what would the perimeter be if x was 1.2? Well, if x is equal to 1.2, I'm going to do the same thing I did last time. And what I'm going to do is everywhere I see an x, I'm going to replace it with 1.2. So right now I have the 15, and I'm going to replace x with 1.2. 2. Now it does have an exponent, so I need to keep that exponent there, minus 12. Okay, so I'm going to figure out what this is. So the first thing I'm going to do is I'm going to follow my order of operations, which is to do exponents first. So I'm going to go to my calculator. I'm going to clear this. I'm going to do 1.2, and I'm going to square it, and that's 1.44. Okay, so this is 15, and then this just changes to 1.44, and then minus 12. Okay, so I'm going to take 15. Okay, I'm going to take 15, and I'm going to multiply it to 1.44, and I get 21.6. 21.6 minus 12, so I'm going to take 21.6 and I'm just going to subtract 12. That's going to give me 9.6. So if the x was equal to 1.2, we would just get 9.6. Now don't forget your units, this was talking about inches, so it must be 9.6 inches. And that would be the perimeter of this triangle if x was equal to 1.2. All right, but notice how I applied adding polynomials here, all right? We'll look at another perimeter example, okay? So here's another perimeter example. It moves. Here we go. Julian is going to build a square pig pen out of wood. The side length of the pig pen is 4x squared plus 3 feet. Julian plans to build a similar pig pen whose side length is 5x minus 2 feet. What expression can be used for the length of wood, because this is being built out of wood, that Julian needs for both pig pens, and what is the length of x equals 2.5? So the first thing to note is that this pig pen is a square, and what we know about squares is squares have 4 equal sides. I know this isn't the best picture, but just trust me, all squares have 4 equal sides. So what I'm going to do, right, is I'm going to, this might be a little bit easier if I draw it first, right? One of the pig pens he builds has a side length of 4x squared plus 3. Right? Now he's going to build a similar pig pen, which means that if this one was a square, then the other one must also be a square, and the length of one of these sides, because it only gives you one side, is 5x minus 2. Now what you're going to do, right, is what a lot of students are going to do is they're going to take this, and they're going to label all the sides, because you have to know that if all the sides are equal on a square, then if this is the length of one side, then the other lengths also need to be similar, all right? And you could do the same thing here. But this question, they want you to think a little bit outside of the box, no pun intended. So they want you to think outside the box. So here's what you're going to do. You know that you're going to take all 4 of these sides, and then you're going to add them to all 4 of these sides. Now, before you add all 4 of the sides, know that whenever you're adding things that are similar, you could always multiply. So what I mean by that is, let's say you had a square that was side length 3. You could say, well, 3 plus 3 plus 3 plus 3. Well, that's just 12. Isn't that the same as 4 times 3? Well, yeah, because whenever you have the same thing and you're adding it to itself a number of times, you just multiply it by that number. So in other words, since I have 3 and I'm adding it 4 times, I multiply it to 4. So what I'm going to do is I'm going to apply this rule to this. So what I'm going to do first is I'm actually going to take this expression, and I'm going to add it to this expression, because either way, at the end of the day, I'm going to need to find the length for both pig pens, so shouldn't I just add the sides already? So what I'm going to do is I'm going to add the 2 expressions. So I'm going to take 4x squared plus 3. I'm going to put that in parentheses, and I'm going to add it to 5x minus 2. I'm going to apply the rules that I already know. All right. So, well, since this is addition, again, you don't have to change anything. So we have 4x squared plus 3, and then plus 5x minus 2. I'm going to take my red color, and I'm going to underline the things that are similar, numbers and numbers, and then 5x goes by itself. Okay. So if I rewrite this, and I'm just going to write down the final answer, these combine over here. This does not combine. So I have 4x squared plus 5x, and then plus 3 minus 2. Well, that's just going to be plus 1. Okay, so this would be the sum. Now notice, though, I only added these 2 sides. You might be asking, well, what about the other 3 sides? You only added 2 sides, and there's actually 8 sides in total, right? So what you do is you take this expression, and what you're going to do with this is this just tells you the sum of these sides. And if you remember a square, they have 4 equal sides. So instead of adding this expression 4 times to itself, because again, this tells me 2 of the sides, so I can add it to itself. That would give me 2 pairs of sides. I can add it to itself 1 more time. That would give me 3 pairs of sides. And I can add it a 4th time, and that would give me all 4 sides. I can just take this expression and multiply it by 4, because either way, you're going to take this and multiply it by 4 to get the total perimeter of this, and you're going to take this and you're going to multiply it by 4 as well. So what they want you to do is they want you to think outside the box and know that you have to multiply this by 4, because you have 4 sets of sides here and you have 4 sets of sides here. Right? Now the final question wants to know, well, how much wood would he need for both pig pens if the length of x is equal to 2.5. So what I'm going to do is I'm going to take x, and again, I'm just going to replace it with 2.5. So anywhere I see 2.5, I'm I'm going to replace it, anywhere I see an x, I'm going to replace it with 2.5, all right? Okay, so there is a lot of things going on here, so what I'm going to do, I'm going to give myself some space. I'm going to use my PEMDAS, right, over my order of operations, so it's going to be 4, and then the 4 is right here. I'm going to take 2.5 squared first, so I'm going to take 2.5 squared, so I'm going to clear this 2.5 squared, and that's just 6.25. This is just times 6.25, right? Then I'm going to add this to whatever 5 times 2.5 is, right? So I'm going to take 5 times 2.5, and that's going to give me 12.5, right? So I do have a lot of numbers here, but it's okay. And then plus 1. The next thing I'm about to do is I'm going to work the parentheses first, all right? So I'm going to work this out first. So I have 4. I'm going to figure out what 4 times 6.25 is, right? So 4 times 6.25, and it should give me 25. Yep, so 25 plus 12.5 plus 1. Next, I'm going to add everything inside the parentheses. So I'm going to take 25, okay, plus 12.5, and then plus 1, which would give me 38.5. So it's going to be 38.5. And then don't forget about this 4 on the outside still. So this is a parenthesis. Okay, so 4 times 38.5. So I'm going to take 4 times 38.5, and that's just going to give me 154. So my final answer is 154. Don't forget your units. So if I'm looking at the units, it does give me feet. So the answer must be in feet. So 154 feet. All right, I'll put FT. All right, 154 feet. All right. Now, let's say you got a little bit confused, right? What you could also do is you could substitute x right here, and I'm going to do some quick math right here. So 2.5 squared, we already said was 6.25 plus 3, and I'm going to do the math. All right, you can check this with a calculator, but this is just 25 plus 3, and you know that this is equal to 28. So you could say, well, one of these side lengths is 28, and then over here, 5 times 2.5 minus 2, that's just equal to, what was it, 12.5, I'm sorry, minus 2, which is equal to 10.5, okay? And again, you're going to take, this is just one side length, so you're going to multiply this by 4, and you're going to end up with 42, and then over here, you're going to take 28, and you're going to multiply it to 4, which is just going to give you 112. So if you take 112 and you add it to 42, notice how you still end up with 154. So you still end up with the same answer. So if you trust me that this process works, where you add the two sides first, then you multiply them by 4, you will end up with a similar answer, all right? And the math works because we're not breaking any rules of math here, all right? Now let's look at one more perimeter problem. This one gives us a picture. Rob is going to cut the grass along the edge of his yard. So there's his yard. The dimensions in feet are shown. Which expression represents the total perimeter of Rob's yard? And if x equals 1.4, what is the approximate length of the yard? So here's what we're going to do. We're looking for the perimeter of the yard that he's about to cut. Now this one, at first you might think, well, hey, this is a square, right? Because it kind of looks like a square. But if you look at it, this has a plus 5, this has a plus 6. So this is actually a rectangle. So if we apply the rules of the rectangle, we should know that this side length is equal to this side length, all right, plus 5, I'm sorry, and then this side length up top is equal to the side length at the bottom. Okay, so there's two things we could do. So I'm just going to take the approach of just adding up all the sides, and this is going to be a big expression, but it's okay. So I'm going to take 4x squared plus 6. I'm going to put parentheses, and I want to keep it together, and then plus another 4x squared plus 6. Then I'm going to add the other two sides, which is 4x squared plus 5. And then I'm going to add another 4x squared plus 5. Now again, since this is addition, the plus signs aren't going to affect anything inside the parentheses. So I can actually just get rid of these plus signs, which I'm about to do. Instead of rewriting it, I'm just going to get rid of them. All right, so I'm going to get rid of all these plus signs, or all these parentheses, I'm sorry. All right, so these dots stay there. All right, here we go. So what I'm going to do is I'm going to take my color and I'm going to underline the like terms, which just happens that all of these are x squared, and then all of these happen to be numbers. So I'm going to take these, and I forget to erase this parentheses. I'm going to take these and I'm just going to add them. So all the reds are going to combine together. All right, so all of these reds, we're just going to combine them together. So they all have x squared, so it's going to end up with x squared. I have 4 plus 4, which is 8, and then plus another 4 is 12, plus another 4 is 16, so I have 16x squared. Then I'm going to take the number 6 plus 6, that's just 12, and then plus 5, that's 17, plus another 5 is 22. So plus, I should write it in green, plus 22. So I'm adding the numbers here. Okay, so this is my expression. But more than the expression, right, I also need to figure out, well, what's the length of his yard if x equals 1.4? So all I'm going to do is I'm going to take wherever I see x, I'm going to replace it with 1.4. All right, so I'm going to take my calculator. I'm going to take my calculator, and I'm going to type in 1.4 squared. It should give me 1.96. So 16 times 1.96. And then plus 22. So I'm going to take 1.96 and I'm going to multiply that to 16, and that's going to give me 31.36. So 31.36, and I'm going to add that to 22. So if I take my sum and I add 22, I should get 53.36. So the length of Rob's yard is 53.36, and his yard is in feet. So this will be the final answer. Alright, and that's how you take the perimeter. That's how you take the perimeter. Alright, so let's look at the last examples, because I think I'm pretty much almost done here. Right, simplifying polynomials. Alright, so let's talk about simplifying polynomials real quick. So when you simplify, remember, simplifying doesn't mean that you're changing things. You're just changing the appearance of something. Okay, so when you simplify something, you do one of the operations, whether it be addition or subtraction. Okay, so which is true about the completely simplified sum of the polynomials, and it gives me two polynomials right here. And what I want to look at is I want to look at the sum. So it's pretty much telling me that I should probably take this polynomial and add it to this polynomial. So what I'm going to do is I'm going to keep these together in parentheses, right? So I'm going to take the first polynomial. Okay, so I have 8x to the 4 y cubed minus 3x squared y cubed. Okay, and I'm going to add, and again I'm using parentheses to keep things together, 8x to the 4 y cubed plus 5xy squared. Alright, so what I'm going to do is, since this is addition, again, I actually don't need the parentheses because none of the signs are going to change, so I'm actually going to get rid of these parentheses. Alright, so I'm getting rid of the parentheses. Alright, and what I'm going to do is I'm just going to take my colors and I'm going to combine like terms. So I have x to the 4 y cubed. So is this x to the 4? No. Is this x to the 4? Yes. Is it also y cubed? Yes. Is this x to the 4? No. Okay, next I'm going to take x squared y cubed. Okay, oops. I'm going to take x squared y cubed. I'm going to underline that green. Okay, now this is not x squared y cubed, so this doesn't actually combine, so this must be something different. So what I'm going to do, I'm going to combine like terms. Now, the first thing I actually noticed real quick is you see this 8x and this negative 8x? They both have the same, they're like terms, but notice how 8 and negative 8, these are the, negative 8 happens to be the additive inverse of positive 8, so this actually goes away, so I actually don't need to combine. So what I have left with is actually this term right here, negative 3x squared y cubed, and then it's going to be plus this last term, which is 5xy squared. Now, what I want to know is what's true about this. So here's what's true about this. The first thing you have to ask yourself is what kind of polynomial is this, right? So how many terms do I have? Well, if you remember from the beginning, to tell the polynomials apart, you need to look for pluses and minus. Now, again, this isn't a minus, this is a negative, so this one doesn't count, but this one does count, the plus sign. So this is actually a binomial. So this is a binomial. So when I added these two things, I actually ended up with a binomial. And besides being a binomial, the other thing it wants to know is the degree. So we're going to go back to the degree section of this. Now, what does degree mean? Again, you're looking for the highest exponent. So remember, since these two are together, I actually need to add the exponents together to figure out what the degree is. So if I take a 2 and a 3 and I add them, this has an exponent of 5. And if I take this, which is a 1, and a 2, that gives me an exponent of 3. So between 5 and 3, which is a higher exponent, well, 5 happens to be the highest exponent. So this happens to be a binomial that has a degree of 5. So binomial with a degree of 5. All right. So let's look at this last example. So this last example is asking a similar question, which is true about the completely simplified difference. So I'm looking for a difference this time, not a sum. So difference, remember from elementary and middle school, means to subtract. So I'm actually going to subtract. So I'm going to take this polynomial, which I know is kind of big, and I'm going to subtract this other polynomial. Okay. So what I'm going to start with first is, since this is subtraction, I'm going to rewrite this, and in parentheses to keep it together, 4a to the 5 b squared plus 2a squared b plus 3ab to the 4 minus, now this is minus, so keep in mind what a minus is about to do, a to the 5 b squared minus 4a squared b plus 3ab to the power of 4. Okay, so what I'm going to do is, again, this this negative is going to be distributed to every single term, and what that's going to do is it's going to cause the terms to change signs. So I'm going to start by I'm going to start by rewriting this. Okay, so I'm going to start by rewriting this. So I have 4a to the 5 b squared plus 2a squared b plus 3ab to the 4. Now this is going to turn into a minus, so minus a to the 5b squared. Okay, b squared. Okay, this is going to turn into a plus, or this one plus 4a squared b, and then this is going to turn into a minus 3ab to the 4. Okay, so what I'm going to do is I'm going to take my color and I'm going to figure out which terms I can combine. So a to the 5b squared. This also has an a to the 5 and a b squared. This can't combine, not a to the 5, not a to the 5, so that's good. I have a squared and b, so is there another a squared and b? Right here, there happens to be another a squared and b. And then the last term I have is an ab to the power of 4, which this also happens to be an ab to the power of 4. So all of these terms, I'm going to combine the pairs of terms, all right? So I'm going to write down my final answer in a while. So I have 4a5b squared minus 1, because remember there's a 1 minus one of them. So that's going to leave me with 3a5b squared. Right, next I'm going to combine the green one, so I have 2a squared b's plus another 4a squared b's, right, so that's going to give me 6a squared b's, and then last but not least, I have a 3ab to the power of 4, that's another 3ab to the power of 4, and if I notice, this is actually the additive inverse, because I have a 3 and a negative 3, and they both have the same variables and exponents, so they actually cancel out, so my final answer will actually be 3a to the 5 b squared plus 6a squared b. Okay, so what does that tell me? Well, it tells me two things. First, I need to count the number of terms. So there's two terms. So this is telling me that this is a binomial. So this is a binomial, and I need to find the degree. So again, these two are together. So this is going to have an exponent of 7. This is going to have an exponent of, instead of 1, of 3. So which is a higher number? 7. So then this polynomial has a degree of 7. So this is the two things that it tells me. So when I actually take the difference of these two polynomials, I actually end up with a binomial that has a degree of 7, right? So hopefully that covers everything you need. I know it's a lot of information all at once, but if you remember at the beginning, if you only need a certain section, I am going to put annotations, or I'm going to put, timestamps at the bottom. So if you need one of these things, like let's say you only need to know the definitions, you'll know exactly where to go. Or let's say you're struggling with additive inverse, you'll know where to find additive inverse. Or if you struggle with just adding polynomials or subtracting, or maybe you struggle with finding the addend, or you struggle with just anything in general, you can look at those timestamps. Now, the last thing I want to leave you with is this. We are using Edgenuity, and the thing about Edgenuity is it's new to all of us, so as teachers, we have to learn how to use the platform and how to make sure that we are on top of grades and making sure the students are working. But one of the things I want to tell you is if you notice up here where your name is, I know it has my name right now, there is a little icon right here for, it looks like an envelope, which is telling you that you have mail. Now this envelope only pops up whenever you have a message or you have an email. Now that email you get is probably from your teacher. So one of the things you got to do is whenever you check in Edgenuity, always check if you have a little icon here for an email. If you happen to have that icon, I suggest you open up that icon and you check your email, because for some reason Edgenuity doesn't send emails to your HCISD email account, but it will send it into your Edgenuity account. So always make sure that you're double checking that, all right? And also check your HCISD email. And please check the Kano Freshman Academy website or your Facebook page or Twitter, because we will be posting other ways to reach us besides email on there. So always make sure that you're checking that. And if you need to contact one of your teachers, I provided all the algebra teachers' emails here. So if you have Ms. Santana, Mr. Worrell, Ms. Ortiz, Ms. Caracheo, Mr. Leffler, Mr. Martinez, Ms. Hernandez, and I didn't put mine, but mine is right here. So if you need one of our emails, or if you need to contact us, we will be checking our emails throughout the day, and we're here for you guys. So we just want you guys to know that anything that you might need help with, like we are here to help you because I know it can be kind of difficult to do it on your own, but hopefully this video cleared up a lot of things, and hopefully the examples are helpful for you, so whenever you want to solve problems, you could take this approach. As always, if you have questions, feel free to email me. Please check this channel wherever it's uploaded, and don't forget to check Edgenuity, Dr. Khan Freshman Academy website, HCISD website, Twitter, Facebook, all that good stuff to make sure that you're up to date and you get the best instruction that you can.